Okay, so hi everyone. I hope everyone can understand me clearly. If not, please say something in the chat. So we are starting now the webinar of the MOOC Malaria of 2022. So my name is Francisco Marquez. I'm the PhD student at the Institut Pasteur of Paris. I'm in the unit of Chetan Chitnis here at the Institut Pasteur of Paris, and we're going to cover some of the topics that you have question and you can answer, and yeah, we're going to reply some of the questions that you have asked us during the MOOC.
Yeah, good afternoon, everyone. Very happy to see that we have at least 30 participants joining us here for this discussion. Thank you very much for your interest in the MOOC on malaria. This is the third year that we are doing it, and we're happy to see the response from around the world, and very good to meet all of you online, if not in person, this afternoon. So we will start with some general topics of discussion based on some of the questions we have received over these last few weeks. But please feel free to ask more questions by writing them in the chat. We'll keep a watch on them, and hopefully we will have answers for you.
Okay, so let's start with the first question, and I think the first question is an obvious one. So what is the status of malaria in the world? So I think I'm going to start replying to this question because I have some numbers here that I can show it to you. So at the early 2000s, the malaria has been decreased. That is true. The number of cases of malaria has been decreased, and so the number of deaths because of this disease. But it is true that during the last 6-7 years, the number of cases and the number of deaths has been very stable. So just to give you some numbers, at the early 2000s, the number of cases were over 300 million. And right now, during the last 6-7 years, the numbers has been in the range of 240 million, 230 million cases per year. And in the case of number of deaths, at the early 2000s, the people that died because of malaria was over 1 million. And right now, the cases have been reduced about 500,000, 500, 600 million of deaths because of this disease. So
yeah, so it remains a major problem.
Yeah.
And we had seen success in reducing the number of cases and the number of deaths over the last 10-15 years. But in the last few years, as Francisco has said, the numbers have been stagnant. And in fact, in the last year or two, based on WHO's malaria report, the numbers have even increased. And that may be attributed to the difficulties of managing the malaria programs during COVID, although I know countries and WHO made special efforts to continue the programs. But I think the problem is not just that. The problem is, I think, in areas of high transmission, such as many parts of Africa, sub-Saharan Africa, also in Southeast Asia, the parts where you have really high transmission, the current tools may be inadequate to move towards elimination and eradication. And that's why I think it's important for continued research at different levels on malaria to be able to drive malaria down to elimination in areas of high transmission.
Yeah. So I think there's one question here that Mr. Sorry for the names. Mr. Mimoun Sageni has asked the epidemiology of Plasmodium ovale and Malariae. So I think the Plasmodium Malariae is very similar to Plasmodium vivax. I think it's in the southeast of Asia, if I remember well, and also in Latin America, in the Amazonia and all.
Well, these are the plasmodia that are less well studied, both in terms of epidemiology and biology. Um, it's, primarily the focus has been on Plasmodium falciparum, which is the one that is responsible for, 98% of the deaths from malaria. But as we drive down falciparum, the next important ones are vivax, of course. Vivax is very important in outside Africa, in Asia, in Latin America. And then you do have Plasmodium ovale and Plasmodium malariae, where we know a lot less about the epidemiology and the clinical manifestations, or the clinical epidemiology and the biology. And those are plasmodia that we need to pay more attention to.
Yeah. Okay. The same question. Okay, so we continue. So we, like Chetan was saying before, like it seems like the tools that we have now, all the, how we are facing this disease is not enough to eradicate the malaria. All right. So one of the questions, there was question is, okay, what should we do if we want to really eradicate this disease, if we can actually be able to eradicate this disease? So from where should we start?
I think, the tools we have today, we have been successful at eliminating malaria from several countries. The last one being China. So, this is it's a large country, and many parts of southern China, southeast China had malaria, primarily vivax in many places, but also falciparum. And this was successfully eradicated or eliminated. But again, this is an area with sort of low transmission of malaria. So in countries with low transmission or even moderate transmission, the currently available tools, which is, use of indoor residual spraying of insecticides, use of bed nets, insecticide treated bed nets, early case detection and treatment with ACTs, artemisinin and combined therapies, is quite successful. Doing it systematically, doing it in a focused manner, tying in research with implementation, etc. It can be done. The real problem is the areas with very high transmission, and there we do need new tools which are sustainable, which means and there ideally a vaccine could help. New drugs are needed. New ways to deal with the mosquitoes are needed. So we do need even better diagnosis or quicker ways of diagnosis, or being able to detect parasites when people are asymptomatic and have very low parasite densities. And of course, then there's the problem of vivax, which is even more complex and which we can talk about separately later.
And you also have to think that, in this disease is also is spread all over the countryside and everything. So in these particular locations, trying to have all these tools to reach the people, to have the people training, to have a medical center that can apply to all these tools, like Chetan was saying, a vaccine or a drug and everything, it's something that is really challenging at this point. So even if we have some effective treatment or solution for the malaria, is really when this treatment is implemented on the field and everything is also giving even more trouble. So I think, it can be achievable. We can achieve this eradication and okay, just there's a question. So yeah, just to finish, I think we can achieve the eradication. And like Chetan was saying, maybe in these low transmission settings, we can achieve this elimination, and with the high transmission is where really things got stuck. So, okay, so we have a question from the chat. So yeah, the same person, Mimuna Sageni, has asked, so what is the planning with Primaquine? Because I don't know if some of you have already know, but the Primaquine is a drug that is used to mainly target the liver stage of the parasite and also the gametocytes, also the sexual stage of the parasite. And the problem that we have with this primaquine is that there's resistance. There's a toxicity problem with this drug, with the primaquine, in people that have this enzyme that is called GSP, that is the glucose 6 dehydrogenase. Glucose 6 dehydrogenase. So it seems like that people are deficient for this enzyme has a problem has a problem with the treatment with primaquine. There are some what's it called, hemolysis because of the use of this drug, of the primaquine. So he's asking, okay, what is the planning of primaquine having this problem of this deficiency in the GSPD?
Yeah, so this primaquine, the real use of primaquine is to treat hypnozoites or the latent stages of vivax malaria. And as I mentioned, vivax is complex, has different biology, which makes it even more complex to control and eliminate. And one of the main reasons is that, unlike falciparum, vivax has a latent stage in the liver, and they form hypnozoites, which can then emerge and come into the bloodstream, weeks, months, or even years later. And when the parasite is in the liver as a hypnozoite, of course, it's silent and you don't know you're infected. And then we don't have any diagnostic tests to identify such individuals. So the only way so we have to find a way to either identify people infected with hypnozoites, develop a diagnostic test, and that's a challenge for those of you in the field who are looking for some challenging problems to work on, or one could do mass drug treatment with primaquine. But the problem is that in areas that are endemic for malaria, there's a high percentage of people have G6PD deficiency, which means they lack this enzyme or have lower levels of the enzymes G6PD in their red blood cells, which makes primaquine toxic, and you end up with hemolysis. And unfortunately, there aren't quick, rapid tests to check for G6PD deficiency, and there are some that people are working on that are in development. But even if you have the test, you still are left with the problem that 15-20% of the people will have these deficiency, and you won't be able to treat them with primaquine. So a rapid test would help, but still not allow you to treat with primaquine. There is a need for new drugs that you can treat hypnozoites with, and you could give to everyone. And that's again work in progress. Then we need drugs like that. Till we have that can be used widely without the risk of for G6PD deficient people, it will be difficult to treat hypnozoites.
Okay, so we have another question from Teniola Lawson. Okay, sorry again for my pronunciation. So I have a question regarding the epidemiology. So are the terms, oops, a big message just come out. Okay, so the question is, okay, are the terms holoendemic, hyperendemic, or mesoendemic still obtainable as it pertains to malaria endemicity?
Yeah, these terms could still be used. Holoendemic, a place with very high levels of transmission, usually throughout the year. Hyperendemic could be regions with, again, very high levels of transmission, but maybe during some part of the year, but still very high. So both in holoendemic and hyperendemic area, you would expect, the children, it's mainly the infants who would get large numbers of episodes, but the older children and adults will have developed immunity. And mesoendemic would be lower levels of malaria transmission, but again, where adults could have developed immunity, or even older children. In general, these are terms that can be used, but I guess now we need to we need to become more quantitative about what we are referring to, and ideally, be able to measure and give key figures such as the entomological inoculation rate, or the age distribution and the number of clinical episodes in different age groups, the levels of immunity in different age groups, parasite densities in different age groups, both through cross-sectional surveys and and also in longitudinal surveys. I think all this data put together would give you really a much more granular and detailed picture of the epidemiology of malaria in a place. And that is, I think, more useful than just these terms. But yes, these terms are used to give just the general idea about the level of transmission and of malaria in a place.
Okay, so we have another question from Al Hassan Sidibe. So, are there DOMs specificity about malnutritious and malaria treatment?
I'm not sure what you DOMs exactly mean.
Yeah, can you please rephrase this question? Are there DOMs specificity about malnutrition and malaria treatment? Like, I don't know, a direct connection between malnutrition and malaria treatment?
Yeah, maybe if you can specify this, what you mean, we will be able to answer you better.
So yeah, so we have another question. So Minua Sageni, so the question is if the rapid tests are sensitive.
Yeah.
Sensitive.
Yeah. Yeah, well, I think rapid tests are still used based on HRP2 or based on LDH. And yeah. These are not the gold standard, but they're places where you don't have the time or you don't have the equipment to really. The gold standard remains GIMSA slides. Yeah. Reading GIMSA slides. Often this takes time, so it's always a trade-off between how quickly you want your result, what equipment is available in the field, and if you don't have the ability to really do the microscopy and GIMSA smears quickly in a remote place, RDTs are available, then one, I guess, should use them. But again, this highlights that we do need to develop new molecular tools which will be rapid and sensitive, and of course specific for falciparum and vivax, and maybe the other species also, Ovale and Malaria, which we talked about earlier.
Well, this is now a very big question. I'm trying to.
We're trying to read a very long question.
Well, the first question, so I'm reading the question from Mahuse Ahmel, and the first question of the rapid test, we already solved it. Because yeah, there's people that doesn't have this not accessible, this rapid, yeah. And then the second question is, what are the numbers of the sensitive specific of the rapid test in Plasmodium falciparum? So I don't know about exact numbers.
Yeah,
we don't know exactly.
I don't know
the exact numbers of the rapid test. But it's true that there's a limit on this kind of rapid tests. And I think the light microscopy is giving you much more details of the parasite, and you can detect a couple of parasites, few parasites per microliter of blood. I think in the case of the rapid test, their sensitivity is a bit better, but still there is some, submicroscopy or asymptomatic infection, like Chetan was saying, that there is still, that we can still not detect them with these rapid tests. These rapid tests are very useful on the field to very quickly detect when they have high fever. The first thing that they do is use the first thing that they do is to use this rapid test to see if they have malaria or not. But still, we have some infections of Plasmodium falciparum, like you are asking, or some other Plasmodium species that we are still not available to see with this rapid test, and not even with the light microscopy. So still there are tools that are being used very frequent, but they're still not very sensitive. Okay, so we move to another question. If a rapid test can be used to detect the deficiency on the GSP.
Is rapid test sensitive? I
Yeah.
don't know. Again, if there is a quick rapid test that is available already, I'm sorry, but I'm not.
No, I don't think so.
This.
You need you need to genotype, no,
Yeah.
to evaluate the. I think you need to genotype there's no rapid test for the GSP deficiency. Yeah? You need to genotype and make a PCR or something like this.
There's another question on the.
Okay, so there's another question. So in certain countries, the Primaquine is recommended at a single dose. And also the artemisinin combination therapy to treat Plasmodium falciparum. They're using these two drugs. So the Primaquine and a single dose, and also the artemisinin combination therapy to treat Plasmodium falciparum.
Yes, it's true that there are countries which are recommending Primaquine on a single dose or even a short duration. The advantage of that is with a single dose of Primaquine, you can probably get away even in individuals with G6PD deficiency. You can give it in a single dose. But this is given not so much to treat the hypnozoites, but more to kill the gametocytes. So it is so that you don't spread the disease. So the objective of this is really using the anti-gametocyte activity of Primaquine, not so much its ability to kill hypnozoites, for which you do need to give the 14-day course. Even a 1-week course is not good enough to clear all the hypnozoites.
So he's also asking if this treatment should be generalized and applied to other countries.
No, it depends on what the purpose is. If if you want to use it to just treat gametocytes, and it's not very clear how effective that is, just to give some individuals and in what settings for treating the gametocytes. But it will not help you to clear hypnozoites in Vivax infected individuals. Now there is somebody has actually responded about the RDTs. Thank you for that, Stephen Lafrie. And he writes the limit of RDT is usually around 50 to 100 MPS. That's
per microliter of blood. What is it?
Parasites per microliter. Expert microscopy may be a little more sensitive. However, there are a number of studies where RDT has been shown to be superior to microscopy. Yeah, so RDTs are being used. And as I said, they're certainly more convenient than microscopy. The problem is, depending on which RDT you're using, you may miss some parasites. Okay.
So we are gonna read some question about that you have during the MOOC.
So keep the questions coming. But till we have new questions, maybe we go back to some questions that were posted during the course in the last few weeks.
Okay, so we are going to talk about the recent vaccine that has been approved by the World Health Organization. Is the RTS vaccine. So what is it here? Is it now?
Is it being used?
So if this RTS vaccine is already being used, and what are the other vaccines that are close to the licensing?
Yeah, so this is it's an exciting time for our field, because malaria for the first time has a vaccine that has been licensed. And it's the first vaccine against any parasitic diseases. And of the 3 major vaccines people have been trying to develop, HIV, malaria, and TB, I think malaria at least now has one. It may not be ideal. It still has limited efficacy of about 40% over 2 years. Exactly. But it is still very useful. And the phase 3 trial showed that, and now also the implementation phase in the three countries in Africa. The data has now been analyzed. They have confirmed the results of the phase 3 trials. They have also demonstrated, because this has now been in several 100,000 children, so they have confirmed the safety of the vaccine, and it clearly has an impact on severe disease, reducing severe disease significantly. So I think it is the first vaccine, and I think now it will probably be rolled out in the countries that were doing the implementation study. It will continue to be used, and now there are different countries who are applying to for funding to buy the vaccine and to implement it in their countries. But so it will be used in many countries. But I think people are also finding many different applications of the vaccine. For example, in places which have highly seasonal transmission of malaria, you could use, because the vaccine in the first few months, first 6 months, it has much higher efficacy than 40%. The efficacy is almost 70 to 75%. So if you have a place with seasonal transmission and you give the vaccine just before the transmission season, then you can have much more significant protection. And then again, you can combine this vaccine with chemoprophylaxis, with, for example, the single dose therapy that they give in several countries now. So, but if you combine that with the vaccine, you get good synergy and much higher levels of protection. So there could be interesting uses of RTSS in different epidemiological settings while we try and develop the next generation of vaccines that have higher efficacy.
So it's important to combine, no? You are saying that it's important to combine the vaccine plus something else in case we don't reach this percentage of protection that we are.
Yeah, exactly. I mean, we should not just depend on the vaccine or hope for a vaccine that as a magic bullet that will solve the problem of malaria and elimination. I think we will always have to think of vaccines in combination with other tools. And here, for the first time, we have a vaccine which can be now combined. So in addition to using it just in the EPI schedule for children, there are people working on this already and finding ways in which you can combine the vaccine with chemo prophylaxis and get higher levels of efficacy.
Okay, so there's another question in the chat from Stephen Opoku. Thank you so much for the question. So should we worry that the seasonal malaria chemo prevention may accelerate resistance to SP and AQ since it is given to children without testing them for malaria?
Well, I mean, with any infectious disease, with any pathogen, when you treat them with drugs or any intervention, there's a biological system, and it will try and you will select for resistance in the long term. So so one definitely needs to keep an eye out for that, keep a watch on that, and come up with strategies to reduce the chance of the development of resistance. And one of the things to do is to combine the drugs. Yeah. And that's what is done with SP and SP in addition to AQ. Yeah. So I think people are, earlier people were combining so far 2 drugs, and now it is thought that maybe even we should combine with 3 drugs, because then you reduce, improve efficacy, but also reduce the chance or the probability of resistance developing. But providing the drug with or without, whether you provide it with or without testing for malaria is not such a big issue. I mean, if you give it to children who don't have malaria, but you don't have the time or the resources, or it's not practical to test each child and then treat them. You're not, because remember, in prophylaxis, you're not giving them you're not trying to cure the disease, you're trying to prevent it. So I think uh, having these double or triple drug combinations and use them for chemoprophylaxis, if it really reduces the incidence and the risk of getting severe disease and has a clear impact on mortality, then it should be used. That's the tool we have, and we must use it, not just worry about the development of resistance. And of course, the only way to counter that is keep coming up with new drugs. So we must have a healthy pipeline of drugs, which we will keep using as long as there is, malaria, and hopefully till we achieve elimination. Only then we can, forget about. Then we can relax and not worry about resistance appearing. Till then, use what drugs you have, use them judiciously, making combinations, and protect as many children as we can.
Okay, we have another question from the chat from Minua Sageni. So if one person pre-immune, I assume pre-immune with malaria, okay, yeah. So if one person that is pre-immune with malaria leaves their country to another place that has no malaria, if it's interesting to prescribe some prophylaxis during this period of during this first month of a stay in this other country.
So the thing is, if I understand the question correctly, you're saying if a person has already developed immunity to malaria, but moves from one country to another, would you recommend prophylaxis? Well, I mean, I guess we don't really test to know whether somebody is immune or not. But I suppose if you're moving from one malaria endemic country to another malaria endemic country, and you're not taking prophylaxis in the first country where there is malaria, if you move to another country with malaria, I would not, I guess you would be less worried because you're likely to have immunity. If I don't know if your question is because you're worried that there may be different variants in the second country to which you may not have immunity. I think if that's your concern, I don't know if there's any real evidence for that once you build up immunity, there's already a lot of variation and variants in places that are endemic, that if you move somewhere else, my guess is you'd probably have some immunity to the variants there too. But of course, if you want to be absolutely sure, no harm in taking the prophylaxis.
Okay, so we're waiting for some questions in the chat, but okay, I'm gonna ask you something about the Plasmodium vivax that we were talking about, the second, one of the most important Plasmodium species. So what is the distinction between from the biology of the Plasmodium vivax and Plasmodium falciparum?
Yeah, there's very interesting differences in the biology of vivax and falciparum. And as I mentioned, outside Africa, vivax is important in many parts. It is the main parasite causing malaria. And in places with both vivax and falciparum, when you employ control tools, it's easier to control vivax, and in fact, easier to control falciparum and more difficult to control vivax. As I said, one of the main reasons is the latent hypnozoite stages. Another reason is gametocytes appear very early following infection. Once the parasite comes out in the blood, the gametocytes appear very early, even before the parasite density reaches the fever threshold. So even before a person knows they're sick and goes and looks for treatment, and if they come for treatment, you can treat them with even gametocidal drugs like primaquine, one-day primaquine, as was mentioned. But even before that, the parasite may have transmitted because gametocytes were already there. So that's the second reason it makes it more difficult to, so early detection and treatment doesn't work as well. And also in many parts of the world, for example, in Southeast Asia, in countries like Cambodia, even parts of India, there is a lot of what is referred to as forest malaria, or where the mosquitoes do not bite you in the house at night, but actually are in the forest, in the fields, and can bite you and transmit malaria when you are working outdoors during the day. And so in such cases, the traditional control tools of indoor residual spraying and insecticide treated bed nets don't have much impact, because the mosquitoes that are biting you are the Anopheline species, are not biting you at night when you're sleeping. They're biting you in the day during your work in the fields of forest. So the mosquito control or methods also do not work in many places with Vivax. So you really need new and different tools and different approaches to be developed to handle Vivax.
Okay, so we have some questions from the chat. So a question from Teniola Lawson. So what are the possible antigenic targets for the malaria parasite that may be effective against all stages of malaria, rather than the limitation of research focusing on targeting antigenic targets for the pericytic states, such as the RTS circusporostoine protein and the blood states separately?
Yeah, that's a very good question. If there was, if you could identify targets that are important both for the sporozoite and the blood stage, in the merozoite, for example, then you could target both at the same time. Unfortunately, we have not found such targets so far. People have looked. There are some antigens that are expressed in both stages, even the antigen AMA1, apical merozoite antigen, which was first identified in the blood stage, and antibodies to AMA1 block invasion. It's essential. There is a problem that it's highly polymorphic, which poses some challenges, but one could think of ways to tackle that. And AMA1 is also expressed in sporozoites, but it doesn't seem to have a function in sporozoites. So if you knock AMA1 out, you can't knock it out for the blood stage. It is essential. For sporozoites, it doesn't seem essential. So that, unfortunately, does not seem to be a good target for both stages. And it also has problems of polymorphisms, but it's one of the well-known antigens that's present on both sporozoites and blood stages. There's an interesting new, it's not a new antigen, but the discovery that it's also on sporozoites is new, which is PFEMP1, the variant genes. So one of the variant genes, or classes of variant genes, has been now found also on sporozoites. And this was actually work done partly at Pasteur in collaboration with another group here in France, the group of Benoit Gama and Arthur Scherf, and they have shown that this is also expressed on sporozoites. What it's doing on sporozoites, what is the function on sporozoites, whether is not clear. So it's still not clear whether targeting it on sporozoites will have an impact. And again, it is a variant antigen. It is one of the VAR genes, so not very clear again how to deal with the polymorphisms. So yeah, it's a very good. That's a good research question for some of you young people who would like to get into the field of malaria vaccines. Try and find a conserved antigen that is expressed both on sporozoites and merozoites and is required for invasion or some function in both stages. If you find that, you may have a good chance of making a vaccine with such an antigen.
Okay, so we have another question where this is actually an acceleration from the question that we had before regarding a person that moves to another country and everything. So he clarifies. So the person is moves. So the person is moving to a country that is not, there's no malaria, but the person has the malaria, has the parasite. So in this case, what is the risk of this person to transmit malaria in this other country that doesn't have malaria, and if the treatment should be applied to this person or not?
Okay, that's an interesting question. And that's this is the kind, that's why we didn't understand your question earlier. So that's an interesting question, especially as some countries are achieving elimination. Yeah. So for example, there are countries in the Middle East, for example, that have achieved elimination. And maybe if somebody from Africa moves to that country, and in these countries you still have the vectors, should they be treated for malaria, or should there be a diagnostic test to see if they are carrying the parasite, so that they don't transmit the disease while they are there? I think this is a good policy question, and I can only guess what might be. I think it would not, probably you cannot enforce treatment for such travelers without first testing and diagnosing whether they are carrying the parasite. So I think it's possible that, but that is possible. This is used to be much more common. For example, in the 60s, if you were traveling from a TB endemic country to Europe, you had to carry a TB test or even an X-ray to show that you didn't have TB, and only then you were allowed to travel. And maybe if there is a real concern of the risk, then but I would guess it would be for the country will have to impose such a restriction, and the restriction would have to then be maybe a diagnostic test, and if you are positive, then you would have to take a treatment. Of course, as I'm saying this would be relatively easy for falciparum, but for Vivax, because you can't detect hypnozoites, you can't do a diagnostic test. And of course, currently, there is no requirement for moving from a Vivax endemic country to a country that's eliminated. There is no requirement to either be tested or treated in such a situation.
Mm-hmm. Okay, we have another question from the chat. So hello, from Stefano Macario. So for resistant Plasmodium falciparum to artemisinin and quinine, he uses this other drug that is called clindamycin when working in Sierra Leone. So which third level of therapy would you would recommend in a case like this? Thanks. Wow.
So for resistant PF to artemisinin and quinine,
he used this other drug.
Working in Sierra Leone, which third level therapy you would recommend in cases like this? I mean, first of all, to say neither of us is a medical person. Mm-hmm. We are basic researchers, so we may not be the right people to answer this sort of clinical question. I know clindamycin is used to target parasitic diseases, but I'm not sure what is the efficacy and whether some other known antimalarials such as lumefantrine,
exactly,
or something may be also used. But to be honest, we are not the right people to answer this.
No, but I would like to clarify that there's a different combination of different drugs that can be used in this artemisinin combination therapy. So my guess is that if artemisinin and quinine are not working, there's different combinations that you can try. Of course, maybe in the field maybe they need to be.
You need something that's working quickly, especially in severe cases. So, sorry. So I don't know if you've come up with the right answer to your question, but
Okay, so there's another question in the chat. Bonjour from Soriba Amara. So she's asking, he's asking, what are the plan, the guidelines, the plan guidelines for the 2023? Could you please specify what is these directives that you are talking about? Sorry, Bamara, I don't know exactly which for which plan 2023 you are talking about. Yes. This is the fight, that is the fight against malaria. I don't know, but I don't know which guidelines or what instructions are for the next year 2023. I don't know if she's talking about the World Health Organization or.
Yeah, I'm sorry, I'm not.
Yeah, could you please specify these questions, sorry, Bamara, and we can reply to you. So, okay. So, yeah, so one question that I would like to ask is, so we are now discussing the topics of resistance and everything. So let's first ask ourselves, so how is this big of a problem of this drug resistance? Like, I don't know, is this something very common that is often seen on the field everywhere?
Well, in a lot of the drug resistance has first arisen in Southeast Asia, as you know, in the in the sort of in Cambodia and the Thai Cambodian border, in that region where Thailand, Laos, Cambodia come together. It's not clear why resistance seems to appear there, first to chloroquine, then to artemisinin. And there it's quite common that you really have to worry about the resistant parasites. Now, artemisinin resistance has also been now reported from places in Africa, a couple of places, but it's not yet as widespread. So, so I think ACTs are still fairly used and effective, but we need to come up with new combinations, possibly combinations of 3 drugs, and protect artemisinin as much as we can, and at the same time come up with new drugs.
So I have one question. So how fast normally this resistance can be transmitted to other countries? Because in the case of the chloroquine,
chloroquine moved very quickly.
Very quickly, right?
Chloroquine moved very quickly around the world, and but artemisinin, for some reason, does not seem to be moving as quickly, and that may be because artemisinin
is in combination
has
therapy.
been used primarily, at least officially, in combination therapies, in combined. Although I'm sure there are all kinds of problems with availability of. I mean, it's probably also available individually. It's probably also available in forms that are not optimal, which then leads to the rise of resistance. But on the whole, it has the spread of artemisinin is not been as rapid as chloroquine.
So we have another question from the chat that is actually linked to another question that we answered. So what's the combination of artemisinin combination therapies that you have tried? I mean, we were talking about these other 2 drugs. So you could switch to another class of artemisinin combination therapy for treatment. Sometimes closing treatment with these 2 drugs after completing the artemisinin combination therapy treatment also tends to offer a longer parasite elimination from my clinical experience. So he's suggesting that maybe change the 2 drugs that are in the artemisinin combination therapy we may help for you to come up.
Suggesting is, so thank you for that, Daniela Lonson. That's in response to the question from Stefano, and I think Daniela probably has experience doing clinical treatment, as a clinician, and what is being suggested is that you can follow the ACT, the available artemisinin combined therapies with sulfadoxine and pyrimethamine after you complete the ACT treatment, to be sure that you are eliminating completely the parasite. So thank you for that insight.
Okay, so we have another question. So, we were talking about the vaccine that is already being licensed, the RTSS, based on the syncosporozoite protein. But I would like to ask you if which are the other leading candidates that we can expect in the future for Plasmodium, maybe not falciparum, but also vivax?
Well, the next vaccine that you will soon see, and which is very advanced in development, is actually a very similar vaccine to RTSS, a vaccine called R21, developed by the group of Adrian Hill at the University of Oxford, at the Jenner Institute in Oxford, and which has been licensed and will be manufactured by the Serum Institute of India in Pune. And they've reported results of the trial from phase 2 studies, the phase 3 studies ongoing, and they have basically used the same or similar design, which is a part of the circumsporozoite protein, including part of the central repeat region, fused to the hepatitis B surface antigen. But they use a different expression system. They express it in a yeast called Pichia pastoris, which is different from the yeast that was used by RTSS. And they get particles with much higher epitope density. And which is why it may be more immunogenic. So their results look quite promising. They also report, in their phase 2 study, which was done in Burkina Faso, over a year, they reported efficacy of 75%, but we have to be a little cautious because this was an area with seasonal transmission of malaria. So they need to do this trial, which they are doing currently, and I'm sure we will soon see data from areas with perennial transmission, different levels of transmission, and they are currently doing those phase 3 studies. So that's the next exciting thing we can look forward to for malaria vaccines. That is, there will be another RTSS-like vaccine, R21, so that it will, which should be also at least as efficacious as RTSS, if not more. Unfortunately, besides that, there is nothing else that is really in an advanced stage in terms of development. For falciparum, for falciparum, the next thing that is sort of in clinical development is attenuated sporozoites being developed by Sanaria. These are, you basically use the mosquitoes as your factory to produce sporozoites, dissect the sporozoites, attenuate them by irradiation, and then use them as an attenuated vaccine. And while this gives protection, there are still questions about how long-lasting the protection is, how well it will protect against heterologous isolates. It's been tested against some heterologous isolates, but there's no field study as yet to see how well it will work in the field. And there are challenges in terms of delivery, that it has to be given intravenously. It requires storage at -80, and so delivery in remote places in Africa could be challenging. But there is another way to develop a vaccine using attenuated sporozoites. There's a lot of research using different delivery platforms to develop vaccines for falciparum. Our group is developing a vaccine for vivax based on the Duffy binding protein, a blood stage vaccine, which we then hope to combine with a circumsporozoite-based protein-based vaccine. So we target both liver and blood stages, but we are in phase 1, phase 2 trials right now. So next to RTSS, we really do need more and better vaccines, but we need a lot more work in that direction.
Yeah. So we have a question from the chat. So from Teniola Lawson again. So Dr. Chetan Chitnis, do you think that the adjuvant used in these late stage vaccines AS01 and Matrix M have a difference in the clinical efficacy of both vaccines, of both vaccines for RTSS and R21 vaccine respectively?
Well, they could be. So first of all, we to really prove or show that there is a difference in efficacy, you need either a comparative study where you test both vaccines in, say, a challenge model or in a phase 2 field trial, or you need very large phase 3 trials, where both have been tested in many different epidemiological conditions and large populations. So I think once the phase 3 trial, meaning both vaccines need to be tested in the similar conditions, only then you can compare efficacy. And I think once the phase 3 trial data from the R21 study is completed, and then we can compare efficacy of the two different vaccines. Of course, endpoints have to be the same. So there's a lot of things that have otherwise to be the same. But I think we'll get a good sense of the efficacy of both vaccines once this phase 3 trial is done. If there are differences, what might be the reasons for the differences? Well, as I said, there are two main differences. One is the adjuvant, as you have pointed out, AS01 versus Matrix M, and that could be a difference. We've could be one of the differences. And the second difference could be just as I mentioned earlier, the epitope density. You see, it's composed of a fusion of the circumsporozoite protein with the hepatitis B surface antigen. And to form the particle, you need to add some more hepatitis B surface antigen. So only about 1/3 of the proteins in the particle have the hepatitis B surface, have the circumsporozoite protein. In R21, you have only the fusion protein. So it's 100% of the proteins have the circumsporozoite antigen. So the epitope density or antigen density in the R21 particle is higher. Now, whether this leads to better efficacy, this could be a reason why it might perform better, but we need to wait and see the data.
Okay, there's another question in the chat, from Siduna Umar, but I would like to the question to be more specific. Sorry, because she's asking about what is the advantage of the post-transfusional malaria? What is the? You mean transfusional? I would like to know the advantage on post-transfusion. I mean, I think in malaria, I would think that you use transfusion only in the case of severe anemia, which is one of the problems of severe disease in children, in infants, in high transmission areas. This is a problem, the severe anemia. And I think this is the only situation in which I think you use transfusion for malaria. Okay. And maybe one last question. Another question from Minua Sageni. So on the vector, so she's asking the tiger mosquito, if there's any possibility of this mosquito to adapt to transmit the parasite. No, it's a completely different genus, different species, and it's unlikely that it can adapt to transmit. Exactly. Malaria has been adapted not to. We can be thankful that at least we won't have a new vector like that. So we are coming out to 3 o'clock. So thank you very much for your participation, for attending this webinar, and for attending the MOOC course. And I hope you're finding it useful. Keep writing to us. If you have comments on the course, on the lectures, anything we can improve next time around, and continue the dialogue. So thank you very much. Thank you so much, and good luck with the exam that is going to be very soon as well. Good luck. All the best, and good luck with your work on malaria.